Good evening. It is April 8th, 2020. I am Professor Torres, and this is Just the Math. This evening, I'd like to talk to you about my concern with social bias in mathematical modeling. And I've been looking at some of the models and on the COVID spread and been concerned that we may actually have some bias. And why would I be concerned about that? First of all the articles I will be talking about are linked below, and this is the Harvard Business Review. What do we do about bias in AI? And why is there a bias in AI? Well, basically, AI is a form of mathematical modeling, and it can occur in all mathematical modeling. So this is an excellent article, talks about the dangers. I'm not going to go too far into it, but it's a problem. And I'd like to go with this paragraph here, starting off with bias can creep into algorithms in several ways. AI systems learn to make decisions based on training data, which can include biased human decisions or reflect historical or social inequities, even if sensitive variables such as gender, race, or sexual orientation are removed. And it goes on to talk about how basically these biases can end up perpetuating sexism, racism, and even regional cultural bigotry. And that is a concern. So, what is my concern? And right here we have this kind of crude map of the United States on Axis. And if you click on it, it'll tell you some important information. And this gives us when the hospital resources are going to be maxed out according to the models currently being used for the COVID-19 spread. And it has California peaking at April 26th. Luckily, because of their good response, that they should have enough ICU beds available according to this information. Florida, on the other hand, is projected to peak 1 week later. And not only are we expected to peak 1 week later, but we're expected not to have enough ICU beds. And this is a major concern. Florida has a very large, in fact, Florida has the largest retirement population as a percentage by any state in the union. And that's important. It's a concern. So, uh, we're going to peak 1 week later. Some other implications I'd like to talk about. This is a Bloomberg article, talks about the same information in a little bit different way, and this was produced on April 6th and updated today, April 8th. So this is current information as I can gather. And what I'd like to talk about is not only the fact that Florida is going to peak later than California, but what the models predict because of that. So Floridians, you should recognize this as like a hurricane cone, the cone of uncertainty. The dashed line is the projected path. Unfortunately, this is the projected path of Florida deaths due to the COVID-19. And our uncertainty puts us between 1,000 and 8,000. And we've seen it many times in the past with hurricanes where they show model after model and kind of look at all the different models and make the best choice we can by looking at the different models. So it looks like we're going to have 3,000, maybe 3,500 deaths in Florida as a result. Now, we look at California. First thing that bothers me a little bit about this publication is we see all the models and none of them seem to be in their cone of uncertainty except for this one little model here at the bottom. And I question why all the models are outside of the cone of uncertainty, but one little model has on the inside, and that has California between 1,000 and 2,000, much closer to 1,000. Okay, so that is an interesting choice on the models. So I wanted to look at some hard data, and what I wanted to look at is the actual cases day by day. And in California, this is linked below, and the cases day by day in Florida, which of course is also linked below, but here's the web page I'm gathering that information from. So I took this data on this little graph right here, and again, the graph from California with the similar information, new cases by day, sorry, not by death, and Florida, new cases by day. And I copied and pasted them in here into my OneNote, and so I could compare them side by side. The 7-day average change here is a projection that goes through it and just kind of smooths the data. Florida doesn't have that, but that's the only real difference. Now I wanted to make sure that clearly my data was as close to being represented the exact same way. And sometimes with different colors, it's easy to get confused on whether this data is actually similar. So the most important thing was to make sure that my 0 for California and the 0 for Florida lined up from left to right. So there's a line going across showing that I have the bottom of Florida and the bottom of California is the same. Also, on the Florida scale, it goes up by 500, 1,500 to, 500, 1,000 to 1,500, and California is going up by 200s. So the highest value that was exactly the same was at 1,000. So I wanted to make sure that the 1,000 for California was the exact same height as the 1,000 is for Florida, and as best as I could do, I made that happen so that my data is accurate from height, bottom to top, and I also did the same thing from left to right. And you can copy this screen on your computer and verify that as well. But it's important because when I look at this data side by side, we notice something really interesting at the top of the data here in California. We can see what looks like and hopefully is their peak. So I'm going to just kind of highlight, let me zoom in a little bit onto this data a little bit closer. And this appears so far as of today, the worst day for new cases in California. And this is the day for Florida, which is the worst day for new cases for Florida. What's interesting is it's the exact same day. Not 1 day difference. California has begun to drop, and that looks nice for California, and Florida has begun to drop. In fact, it actually looks like Florida right now, and it's way too early to make any long-term predictions, but right now it appears that the rate of new cases is dropping faster in Florida than California. Now this is important because when this is going to hit the hospital is not the days that we have the most new people detected with the virus, but when these people get detected, it's usually a few days later before they end up in the hospital. So, and we've got a lot more people that are still getting sick, and you're going to be in the hospital for maybe a week if things don't go well. And that's a concern because what we're really talking about is the ICU rooms. And that's the people that we're concerned about is do we have enough ICU beds? And they're going to be in the hospital for some time. So it takes a while for all of those people to build up. But again, if the peak is a week difference in hospital beds, then you would expect the peak from the number of people being infected to also be different by about a week, and it doesn't appear. Now, this is just hard data here. There's no potential for bias. I've got my axis lined up, got the same bottom, got the same heights values. It's this pure data, and from this pure data, it's not really looking to me like Florida is 1 full week behind California. In fact, if our drop in new cases pattern seems to hold, and let's hope it does, then we may peak before California, not a week after. That's a huge difference. So where did the models get the prediction that was so different? And that is my concern. Is that a potential for bias against what's happening in Florida? Now, if you have that bias and you data produces that bias in its projections, and then you go on the news and you report that bias, well, then you spread and you reinforce the regional biases about who's doing what they're supposed to and who's not doing what they're supposed to. And my question is that being represented in the data? And my concern is right now, I don't see that being represented in the data. All I can say is it's just the math.